As you might imagine, this type of ruled surface is created normal or perpendicular to the surfaces that surround the selected edge. If I select the oval edge again, you can see the result is a surface connected to the edge, in a direction normal to the top flat face. Here again there is some ambiguity. Should the surface be created upward, away from the surface body, or downward? You control this, not with the alternate face button. We are using the same flat face as a reference, but with the direction button next to the distance field. Let me clear the edge selection once again and move on to the taper to vector type. This type of ruled surface allows you to introduce a draft angle to a ruled surface. When this type is selected, notice a change in the property manager. The direction button is gone and two new fields have appeared. One prompts me for a reference vector, the other for a draft angle. As the reference vector, I'll select the bottom flat face of the model. A preview arrow showing the vector direction appears in the graphics area. To reverse it, I can use the direction button that now appears next to the reference vector field. I'll leave it pointing in the upward direction. Next, I'll enter a draft angle of 10 degrees. Finally, I'll select the oval-shaped edge. You can immediately see that a surface ruled by the oval edge is created with a 10-degree draft angle measured in the upward direction. Again, I'll clear these selections and move on to the perpendicular to vector type. This is similar to the normal to surface type, except that instead of the normal direction being defined by the edge's surrounding surface, it can be defined by any reference vector. In this case, I'll select an angled side face as the reference vector and the oval edge. You can see the surface is created in a direction perpendicular to the vector defined by the selected face. Finally, we move on to the sweep type. If you've created a surface sweep, you know you must create a profile and define a path to sweep the profile along. The sweep type of ruled surface is a quick and easy way of sweeping a profile along a path. The profile must be a line segment. The path can be any selected edge. I'll need to select a reference vector. For this, I'll use the top flat face. Notice you can also enable the coordinate input option and use Cartesian coordinates to specify the reference vector. Next, I'll select an edge, or in this case, edges. I want to use the lower edge that goes all around the model. To do this quickly, I'll right-click one of the edges and use the Select Tangency option. The result is a ruled surface connected to the lower edge. I can change its direction using the Direction button next to the reference vector field. I mentioned before that this was just like sweeping a line segment along a path. The path is easy to visualize. It's simply the lower edge of the model. The line segment is the cross-section of the surface. It starts at the path, extends in the direction specified by the reference vector, and its length is defined by the distance you enter in the property manager. If you've ever had to create a swept surface that uses a single straight line as its profile, you'll appreciate how much easier a ruled surface can be. Of course, you do lose the benefit of guide curves, but sometimes the reference vector can be just as useful, if not more. I'll click OK, and the ruled surface is complete.